Hello and welcome to another episode of AI Security Ops with my illustrious colleagues Brian Furman and Derek Banks. Welcome, gentlemen. As usual, this episode is brought to you by Black Hills Information Security. If you are interested in an AI assessment for some AI application framework or local model deployment or whatever your context is, please feel free to reach out to us. You can find us by visiting the website, blackhillsinfosec.com, and clicking on the Contact Us form. Today, we are going to talk about model evasion attacks in the realm of AI security. So I think the first thing is, what exactly are model evasion attacks, right? I mean, how do attackers evade machine learning models used in security tools? And what exactly is going on here? So maybe I'll let Dr. Brian Furman set the stage for us. What have you got, Brian?
Sure. When we're talking about model evasion attacks, we're talking more about models that are doing some kind of a classification, whether that be kind of traditional classifier models, random forest, decision trees, support vector machines, or you could be using large language models to do classification tasks as well if you want to. But basically something where you're giving input, and on the other side, what's coming out is some kind of a classification, a determination that's being made about that input. And in the context of cybersecurity, typically what we're going to be looking at is malicious or not malicious, normal or anomalous, and then maybe some kind of a scale in between there. And when we're looking at model evasion, what we're looking at is somebody who is intentionally trying to trick that classifier such that they give it something that is doing something that's bad, is doing something malicious, is doing something out of the ordinary, but ultimately ends up getting classified by the model as normal or benign or not bad, whatever you want to call it, but basically tricking it into misclassifying whatever behavior or malware sample you might be providing to it.
Gotcha. So, I think one of the ways people can really get a sense of this is in the space of visual image classifiers, because that's one of the really early successful stories in AI models, right? We did a lot of visual identification work, even as far back as a decade or more. And I've heard that with an image that you are pushing into a model for classification or identification of some sort, it doesn't take too much in the way of pixel modification to actually get that model to misclassify. So thoughts on that, gents?
I mean, I think that, from my experience, that's been pretty true, because when you talk about image classification, what's happening is that image, and, the same thing happens with, with text or audio when it gets put into any kind of model. And, drawing distinction again is like, this ecosystem, we have large language models, but there's all these other types of models out there, right? And so when you talk about image classification, those are typically like machine learning or statistical learning models. And what they do is they take the image in and it treats, the image as like a grid of pixels, and that's the numerical vectors that get put into the image classifier. And often you can change the picture where the human eye can't tell, but it still looks like, a different, to the computer, it looks like a different picture. And so I think that, that's what I think of. I always think of Minority Report and, the eyeball thing, right? Like that's the model evasion. But probably more practical would be, getting past phishing or malware by introducing some kind of noise into the sample. The same kind of ideas with the picture. You're just introducing data that makes it not look like the thing. One of these things doesn't look like the other, right?
Yeah, absolutely. So, okay, so that's the example of images, and we all know that convolutional neural network technology is typically applied to image classification from an algorithmic perspective of building the model architecture. But that kind of technology is really not very different when we're trying to classify other things. And so one of the classic applications that's out there of AI models is to perform classification on malware samples, for example, right? So I think very much because everything in data science and in AI and ML is largely turning this source data into vectors of numbers, I think the same kind of principle applies here, that if you manipulate the malware just a little bit, you can find out that sort of threshold where you can get this misclassification to occur. Thoughts on that, Brian?
Yeah, and so that's it's kind of the general approach, and I think a lot of people have probably been doing this for years now without really realizing what exactly what they're doing, right? Which is where you're trying to develop a piece of malware that's ultimately going to get past some EDR that you might be going up against within your engagement. And so what do people typically do? So you'll run it, you'll see that it gets caught. Okay, now try changing some way that some function in there, maybe how you're creating a process, or how you're actually putting the shellcode into memory, or how you're storing the shellcode within the program, or pulling it down from somewhere else. What's that?
Or deleting the comments.
Yes, yeah, exactly. And so you start trying all these things until you find the thing that allows you to get past whatever model you're going against. Now, what you're going against might not necessarily be like a machine learning model per se, but it could also be. And so really what you're doing is you're finding those decision boundaries, and you're finding that, hey, when I have a program that has these specific traits inside of it, it's more likely to get triggered or flagged as malware than if I don't have these. And so you start playing around and figuring out what traits can you actually have in there, what pieces of code and functionality can you actually have in there, but still be allowed to get past these different classifiers you might be going up against. Finding that exact boundary, basically.
In a very real sense, what we're doing here is kind of exploiting the feature classification design of some of these neural networks, right? Because if we can pull on a string that isn't in the feature classification of the model and succeed, then we could potentially get misclassification. So I think that's it's an important thing to realize. And then the other thing I think we need to point out too is that when you're dealing with model evasion, you're looking at a process that is playing out when the model is doing inference against the sample data that's being supplied. So typically this is not something that is related to model training. And I think there's a lot of actual confusion out there. This is one of Derek's favorite pet peeves, actually, that, people, when they look at especially LLMs these days, they tend to think of their prompting as if it were training, and that's not the case when you are prompting in the LLM. Yeah.
It reminds me of anthropomorphic fallacy. Like, I still catch people doing this all the time, like making like the AI like it's some giant knowledge thing in the sky that we are all talking to, and like it's an entity. And I don't, that's not how it works, right?
Yeah. But that's not to say that there isn't a possible attack vector on the supply chain side through data poisoning, and that would be impacting the training data that is going into the training process. And that concerns me a lot. We don't hear much about it. I haven't heard of many public instances, or at least companies willing to go public with instances where their training data has potentially been poisoned. But I do know that a lot of data scientists, when they're developing these machine learning operational pipelines, their primary focus is not cybersecurity, right?
Yeah, probably an easier, I'll say easier, another mechanism or another thing that would lead to, evasion would be model theft, right? Like if you get your hands on the model, or you could reconstruct it in some kind of way, it would give you a better opportunity to then test your trial and error, not against the live thing. And, a case that I can think of, and I know I've brought it up on previous podcasts, is the folks from here at Dreadnought now that back in, I guess 2018, I think it was. Can I ever remember the date when they did the talk at DerbyCon about bypassing Palo Alto? The way they did that was, or bypassing Palo Alto's spam filter, the way they did that was they were able to steal enough data to essentially recreate the classifier on the back end, and then were able to trial and error figure out like what words would kind of fly by if it was in the data, right? And so I think that sometimes, sophisticated threat actors will chain things together, be it supply chain or model theft or something, to then get past other defenses.
Yeah. It's an interesting conversation, right? But to sort of distinguish between the supply chain, the data poisoning side, is what I would think of as a supply chain attack, essentially, and the actual inference time style attacks. And I think you started to allude to this a little bit, Derek. There's also the idea of modifying the binary model itself. I guess binary is not a good term for that, but we are aware of model ablation techniques where the weights get tweaked and parts of the model get sort of pulled out. That's an attack on the actual model objects themselves, or the vectors, if you like, of numbers that are essentially all a model is a bunch of vectors of numbers that are stored right in a data structure. So that's a different entity as well. So I think we've kind of talked around how the attackers do it, but is there anything else on the how we attack side that we need to bring forward here?
I think we covered most of it. And kind of is what Derek was talking about with like model extraction attacks, in terms of, you throw enough samples at a classifier. I mean, you're going to eventually learn enough information that you can probably then make some inferences of your own of how how your target classifier is deciding whether or not something is good or bad, coming up with what features you think it's looking at, and then finding ways to kind of play around and mess with those features to try to get past it. Research work I did on my dissertation, which I brought up in a previous episode, was about VBA malware classifiers, and that's essentially what it did. Is you just create a bunch of VBA samples, throw them at the classifier, get classifications back on it, good or bad, add new features to it, modify existing features. And then eventually what you come up with is you essentially come up with like a good list and a bad list of thresholds. Like, hey, if you have these feature characteristics, it's probably going to be bad. Otherwise, it's probably going to be good. And then from there, it's just a matter of modifying your malware to kind of fit those, which is easier said than done, because when it comes to images, which we talked about early on, you're just modifying pixels. And at the end, you're still going to have an image, right? But when we're talking about modifying executable programs, you're not necessarily still going to have a working program if you make the wrong modifications.
Yeah, I was going to say there's things you can do, like in the NT header, for example, in an exe or a DLL. But there are things you can do that are benign. Then there's things that you can do will totally destroy the functionality of the
the things we've talked about. Images are probably the easiest. Phishing text, okay, yeah. I mean, not easy, but easier than a binary that has to work.
Yes.
Well, and the other point I wanted to bring out too is something that I think people miss a lot of the time, and that is this concept that all AI models are data driven, and because they're all data driven, they're all probabilistic in the results that they produce. And what that really amounts to is non-determinism. Whereas the traditional algorithms we use in deterministic technology is that's almost everything in InfoSec up to sort of this point in time, or around about this point in time. So, and the reason I bring that up is in the model evasion attack space, you might try an attack once and it not work, and you might try the exact same attack another time and it then works. And that's, it's due to the fact that these things don't necessarily follow a straight path, and they're probabilistic in nature. Yeah, so myth busting, first of all, right? AI stops 0 days. No. AI does not stop 0 days.
Well, by definition, nothing stops a 0 day. It gets detected, and then people figure out how to stop it, right? But that is a good one, right? I was thinking when I read that, I was like, AI stopped 0 days. I kind of wish, although I'd probably be out of a job. But one of the most high profile 0 days here recently was the Palo Alto vulnerability earlier this year, where from the outside there's remote code execution and footholds on the Palo Altos, and And do you all know how that got caught by Velexity, which was the company that found it?
I do not. Please enlighten
Yeah,
us.
network monitoring on the outside. Now, I suppose AI could have caught it, but also it was just curl commands coming from originating from the firewall, going off to pull down Python scripts, which typically isn't what you want your Palo Alto doing.
Yeah. Yeah.
So, yeah, that's how it got caught.
It also comes down to that, when you add more functionality to a network infrastructure device, that functionality could be abused, right? So it's, I will say, while AI, can't necessarily stop 0 days, I think it does have a better chance of detecting 0 days or things like that because it is probabilistic and not deterministic, right?
Yeah, I think
and that's the big difference.
Just looking for anomalies in general, looking at large patterns of data, AI models are better than humans are, right? So, if it starts to blend into statistics versus AI, there's a gray area in between.
So I think the other thing that's going on here, and the trend is, threat actors are integrating adversarial behavior as a standard capability, and they're also integrating more adaptability. And the AI tech goes both ways, right? The threat actors are using AI to generate more evasive entities to attack different networks,
or do the whole attack itself, as we'll talk about in a future episode.
And, if I've done this, anybody's tried to code like polymorphic malware knows that it's a really difficult thing to do. But for you to code a malware sample up as a proof of concept and send it into an AI and say, make this thing more polymorphic, that's not a difficult thing to do for an AI model. And it is definitely a trend that is out there in terms of, leveraging AI as the attack animal. And I always picture, in fact, I did a slide recently on this. I always picture like AI used for defense, AI used for attack, and them like going into a sword battle, right? Because we're definitely entering that kind of world, as we're watching these trends evolve. And from a pen test perspective, we absolutely are in a situation where, penetration tests and red teaming is happening against AI components directly. And we all are very familiar with that. So let's pivot to defensive strategies. What can organizations do in the context of model evasion? Maybe Brian's turn to talk.
Yeah, sure. So there's a couple things that people can try, depending on how much control you have of the model that you're using for doing the detection. Obviously, if you don't have the ability to train and tune the model, then some of these things aren't really going to apply to you. But let's say if you're a company who develops this product, a model, a classifier type product, then things that they can look at doing, which are what's called adversarial training, which is basically you take samples that have been slightly modified, but are still malicious, and then feed those in as part of the training process to kind of broaden the scope of what a classifier has seen. But there becomes a point of diminishing returns, right? Because you start to get into that gray area where you're going to push it to where basically everything is going to start looking malicious, right? Really what the holy grail is, and any cybersecurity aspect, especially within these EDR and detection products, is basically catching everything that's bad and not alerting on anything that's good, right? And so if you're trying to pump as many examples as you can into your training process, it's going to all start to look the same basically to it, and it's just you're going to lose a certain sense of quality when it comes to your overall classification out of the model.
Yeah, I think that something that occurs to me a lot is that people think like AI is going to take over everything in terms of defensive capability, but I think the best things that we're actually seeing in terms of defense is sprinkling in AI where it is most effective, but not for everything, right? Mm-hmm. Some deterministic technology is still really good for parts of your defense strategy.
What I keep reminding people over and over again, and I just did it today, was that just what you were saying, AI isn't going to take over everything. It's a tool like anything else. And, people get kind of, it seems like we're dividing into I hate and I love AI camps. And I think that's the wrong idea to look at it, because if I'm going to go like fix an engine, I need some wrenches and a socket set. I don't need, a table saw, right? I need to pick the right tool for the job. And so to your point, where the tool fits is where it should be used.
Yeah, 100%. It's I think I had a Twitter post the other day. I said, just because you have AI as a hammer, everything is not a nail, right? Everybody back off a little bit here, right? And think about what you're doing. And sadly, we've seen sort of a degradation in some of the security mechanisms that are in the scaffolding around AI applications. So things are not necessarily happening for the positive in some of this. That's a tangent and not necessarily directly related, but it is important. For organizations who are thinking about acquiring some sort of AI-driven solution for whatever their information security task is, what kind of questions should the organizations be asking these vendors who are sprinkling in ML and AI in all their buzzwords?
It reminds me of Craig Vincent telling me not too long ago, man, people are shoving these large language models into everything. Yeah. Well, I think my first piece of advice would be that AI is not magic secret sauce. It's a specific type of thing that covers a lot of technological areas. I would say, first of all, have somebody on staff or send somebody to training to learn about what AI is and what it is not, and what it can and can't do, and then kind of determine like what business problem you are trying to solve, and picking the right tool for it. And maybe AI-driven technologies are a right kind of fit. So,
yeah, thoughts on that, Brian?
Yeah, absolutely. I think just having those realistic expectations of what it can and can't do. Don't buy the whole line of, oh, it's gonna detect all these unseen threats. Like, well, not really. To a point, right? It has to have seen at least some aspect of it before. Otherwise, it likely isn't going to detect it. It's just gonna, it's gonna look like benign behavior.
Or it's either going to tell you, I've seen like this thing and it matches the pattern, right? Or it's going to say, this doesn't look like everything else. Somebody should go take a look.
Yeah.
Like those are
exactly.
really two options, right? So
yeah.
Right. And it is all in the training data, right? It depends on very high quality, well curated training data to how effective that model is actually going to be at the task that's being put in front of it. So, I do think organizations should consider asking any people that are providing some sort of AI-driven service, like, is this a homegrown model? What is the source and quality of your training data? Actually put those questions out there to see whether the vendor will respond. Now, in some cases, the vendor might invoke the cone of silence and say, no, that's our special proprietary source, and we can't tell you about that. But it's still worth putting that question out there.
It sounds like you don't want my money.
Sorry, no acquisition for you. But all right. So what about the future outlook? Is the future bleak? Is the future rosy and shiny?
Specifically with model evasion, or are we just talking about the future?
Well, I suppose we should keep it in context.
In
model
context of the model evasion stuff, hacker's going to hack, right? I don't think it's going anywhere. Model evasion is going to be a thing forever.
Okay, so interestingly, this part always fascinates me is the regulatory front, right? We all know that Europe has championed being very proactive on this, whereas the United States generally is very reactive on the regulatory front. However, I think there is kind of a convergence out there of people wanting more transparency into how models are actually constructed. Thoughts on that, Brian?
Yeah, basically, so we're talking about the training aspect of them, or kind of where all this data is coming from. Yeah, I do think that those are important questions, certainly for people to be asking. Why is it making the decisions that it's making, and how well does it do against new things that it hasn't seen before? What kind of robustness testing are they doing against the model? Will they allow you to do robustness testing against it? Because some companies, they'll collect telemetry and they'll shut you down if they think that you're actively testing their model to, see how well it does. And, I think being able to have that level of capability in your environment to be able to test the products that are in your environment, I think is important, and to have that discussion with the vendors.
You say that like it's happened to you.
Yeah.
Maybe. We'll not comment.
Well, also the third thought occurs to me, if you're dealing with a vendor that's proffering, I can't remember. What is that word? That is trying to sell you a solution. I'm like brain fighting on whatever word I was trying to come up with. Are they going to publish their internal test results for you? I mean, are they going to give you something that gives you some assurance of the capability of that model? And I think they should. And will we get regulatory backing for that? I just don't know.
I think we're going to have AGI before we have that.
Yeah, possibly. All right, let's have some closing thoughts. All right. So, ML is powerful. Machine learning, that is. But with great power comes great responsibility, and evasion is a real and ongoing challenge. So any other, just from the panel, any other closing thoughts?
Yeah, I think that last one kind of sums it up, right? It's going to be a continuing arms race. With every new defense that comes out, there's going to be a new attack tactic that comes out as well. Because I mean, at some point, like you have to let things happen in your environment, right? Like people have to be able to do things in your environment, and as long as people basically are able to do things on the computer, I mean, there's going to be something that they can do that's going to get around like some of these different detection products. And it's going to be a constant back and forth, but it really pushes like each side to keep upping their game. And where the peak of that is, I don't know, but we're certainly going to see improvements on both sides as in the years to come.
I think another really good point here is, organizations that are considering deploying applications that are leveraging AI, or even they're training their own models and embedding them in some of their own applications. Don't forget, you got to defend the model itself, right? We've all talked a lot in the past about prompt injection in the case of natural language processing and LLMs. And, there's nothing we can do about that, right? That's a feature. It is not a defect. And I think it's a feature we're going to be struggling with for years. And there's all kinds of guardrails people put around that stuff to try to address it. But with simpler models, defense is still required. Even if you have a simple classification model, even something as simple as like API throttling against the requests that are coming at it to prevent potential denial of service for computationally expensive inference is really, really important. Any other closing thoughts, Derek Banks?
No, I think that pretty much wraps it up for today.
Well, okay. Well, thanks again, everybody, for visiting and attending AI Security Ops and another exciting episode. We will see you next time. And remember, keep safe and stay prompting out there. Bye-bye.